Okay, hi everyone, this is Mr. Kurm, and today we'll go through the very first standard of 0580, which is 1.1 types of number. Okay, so I'm going to go through the exact what you are supposed to know. Okay, so first you will have natural number. So what are natural numbers? Simply put, it's going to be things like 1, 2, 3, 4, so on and so forth. Okay. Some of you may have a question whether zero is in the list. So Cambridge is where um, they have not exactly defined whether zero is in the list or not. If you go to different syllabus, you will see some syllabus agrees that zero is in the list, but some syllabus say that zero is not in the list. It is still up to a debate, and for Cambridge, they are not going to test you this whether zero is in the list or not, so don't have to worry about it. Just need to know when they ask you list down the natural number in this set or whatever to answer this question. Make sure you know you don't go into the integer part, which is integers, which can be -3, -2, -1, 0, 1, 2, 3, so on and so forth. And before -3, you also have -4, -5, so on and so forth. All right, so those are integers. Okay, so natural numbers, or sometimes they can say positive integers, or even non-zero non-negative integers, then it's going to be kind of like natural numbers. All right. Next up, we have prime numbers. So what are prime numbers? Prime numbers are numbers with exactly two factors, one and itself. Okay, so you may ask, what are factors? All right. So here we do have a word here, which is factors. So what are factors? Okay, so we'll have things like, okay, let's say what's a factor of 12? Okay, so in order to get the factors of 12, we need 1 times 12, 2 times 6, 3 times 4. Okay, we also have 4 times 3, 6 times 2, and 12 times 1, but they are going to be exactly the same multiplication. So the list of factor of 12 is going to be 1, 2, 3, 4, 6, and 12. Those are the factors of 12. All right. Okay. Um, Next, we okay. So now we go back to prime number and see, what kind of numbers only have two, exactly two factors, which is one and itself. We will have, okay. Let's start from zero. Okay, zero. Okay, doesn't really make sense if you think about it. Zeros will, if you multiply zero with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, even 1,000 or billions. Okay, it's zero times that number is going to be zero. Okay, um, so we will go to one. One have one times one, so it's gonna be repeated, which is, if we talk about distinct factors, it's gonna be one only. So one is not a prime number. Next one is two. Two is two and one. Okay. Three, 5, 7. There's no 9. Okay. Because 9 has 3 times 3 in it. So there are three factors, 1, 3, and 9. Next is 11, 13, 16, 17, 19. No 21. 21 has 3 times 7, 23. No 27. We're 29. 29. Okay, we have 31. We don't have 33. we have 37, 39 is not, okay? So on and so forth. Okay. So here are the prime numbers. Okay, why do mathematicians concern themselves with prime numbers so much? It has a lot of it has a lot of applications, all right. One of them being RSA, encryption. Okay. Um, Even your identification card, your ID numbers, it's rely on the concept of prime numbers. We have something called the uniqueness of prime factorization, which is to say every number will have a unique way of multiplying from prime numbers to itself. Okay, we'll go through some of it in this syllabus. You you will kind of understand how the unique identification number works. Okay, but you don't exactly get to know how it is done. Okay. Next up we have square numbers. All right. Okay, so what are square numbers? Square numbers are okay. Let me move this first. Square numbers are the numbers that get you know gets it is a product of a square of a natural numbers or an integers. All right. Okay. Let's say zero squared, one squared, two squared, three squared, four squared. Okay. Actually, what are these exactly in terms of geometrical interpretation? So for geometrical interpretations, you will see that, oh, let's say two square. Two square is exactly one side, being two, and a square is gonna be the two same side. So the area, okay, area is going to be of this square, area of this square is going to be 2 to the power of 2, which is 4 units squared. Okay, so it's gonna be the same for let's say 3 squared, all right, and so on and so forth. So you have the first few square number being 0 squared, which is 0, 1 squared, which is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 36, 49, so on and so forth. All right, those are square numbers. Which is also the reason why this is called 2 squared, 2 squared, right? Okay, next up is cube numbers. So it's a very similar concept, cube numbers. It's going to be, 0 to the power 3, 1 to the power 3, 2 to the power 3, so on and so forth. So what are they? They are actually, you know, let's say a 3 here, and then you draw a cube here, this. All right. So every side here is gonna be 3 times 3, and then here is 3. Okay. So the volume of this, okay, volume of a cube, which is equals to a side to the power 3, which is 3 to the power 3 is going to be 27 unit cube. So again, we call this 3 cubed, which is 3 to the power 3. All right. Okay, so we have gone through a few, and then next up we'll have common factors, common multiples. Okay. So what are common factors and common multiples? Okay. So we have common factors of, I would say, let's say we want to talk about 18 and 24. Okay, so what are common factors? All right, so there is a very simple way, which is we list down what are the factors of 18 and what are the factors of 24. So 18 is going to be 1, 18, 2, 9, 3, 6, no 4, no 5. Okay, 6, 6, 3 again. Okay, okay, 24. 24, we have 1, 24, 2, 12, 3, 8, 4, 6, and then 5, and yeah, that's it. Okay, and then we will choose the common one, which is definitely 1 is common, 2, 3, no 4, 5, 6, 9, 12, no more. All right. So we will say the common factors of 18 and 24 is going to be 1, comma 2, comma 3, comma 6. Yeah, that's it. Okay. Now moving on to highest common factor. Okay, even though it is not listed here, it is not listed in the identify and use on this side, but it is included in example task input, find the highest common factors. All right, so you need to know how to find the highest common factors. Which, yeah, you can read off from here and say it's 6 because 6 is the largest of this list. But what about things that are so big? Let's say 10 times as big. All right. What is going to be the highest common factor of 180 and 240? Okay. Um, some of you may be able to see that it's just times 10 to the highest common factor from the previous two. Uh, but that is in the exam they are not going to. Well, okay, they may be lenient to give you this, but that's not the intended way of doing things. All right. So the intended way of doing things, I'm going to show you. It is prime factorization. Okay. So we need to use prime factorization. All right. So now we have 180 divided by 2, which is 90, divided by 2, 45, divided by 3, it is 15, divided by 3, it is 5, divided by 5, it is 1. And we'll stop when it is 1. All right. 240 divided by 2, 120 divided by 2, 60 divided by 2, 30 divided by 2, 15 divided by 3, 5, and 5, 1. All right. So we are going to rewrite this as 180 equals to, okay, as you can see here, 2 to the power of 2, 3 to the power of 2 times 5, and 240 is going to be 2 to the power of 4 times 3 times 5. All right. Okay, now for the highest common factors, okay, we are going to 180 and 240. We are going to, choose the highest possible number. Choose highest possible combination that appear in both of the numbers. What does that actually mean is we are going to choose, okay, let's say 2 to the power of 2 and 2 to the power of 4. Okay, so with the highest possible, and it has to appear in both numbers. Okay, so now 2 to the power of 2 appear on the left, but and it also appear on the right. 2 to the power of 4 appear on the right, does not appear on the left. In 2 to the power of 4, you have 2 to the power of 2. Okay, simply if you look this and hand this, yep, so they are 2 to the power of 2. All right. So your highest common factor is going to be 2 to the power of 2. And now 3, because we have 3 here, we have 3 to the power of 2 here, which also have, more than one 3. So it's going to be one of 3 is going to be in, and finally 5, because both of these have 5. All right. So simply put, this is going to be equals to 4 times, I want to do 4 times 5 first, and then times 3, which is 20 times 3, which is 60. Okay. Your multiplication skill, addition skill, which is called mental arithmetic, has to be strong, because we have something called no calculator requirement. Okay, so you will not be able to punch in the calculator to get everything you want. All right. So get good with no calculator first, and then when we go to calculators, if you want, I will show you some, techniques to use a calculator to, get a lot of shortcuts on this. Okay, now we have common multiples, let's say of 18 and 24. So what are multiples? Okay, multiples of 18. It is going to be 1 times 18, which is 18, 2 times 18, which is 36, 3 times 18, which is 54, 4 times 18, which is 72, so on and so forth. All right. And then you have 24 times 2, which is 48, times 3, which is 72, times 4, which is 96, times 5, which is 120. Here I am going to extend a little bit more. 18 times. Okay, now um we are going to see that we have a few common multiples here, 10, 72, and 144. All right. Okay, so how do we get lowest common multiple of, let's say, 180 and 240? Okay, and just now we got the prime factorized product here. So I'm going to copy. And yeah, we are going to find the lowest common multiple. Okay, so this lowest common multiple, we are going to choose the lowest possible combination that covers both numbers. What does that mean? That means we are going to choose. Okay, let me bring it down here. What that means is we are going to choose, the lowest possible, but can need to cover both. So lowest possible, is it 2 to the power of 2? Or is it 2 to the power of 4? Okay, 2 to the power of 2 cannot cover 2 to the power of 4. But 2 to the power of 4 can cover 2 to the power of 2. So we are going to choose the one that is going to cover the higher one, because it can cover both. Okay, higher doesn't mean highest. Here actually means the lowest possible to cover both. All right. Okay, 2 to the power 4, 3 to the power 2, and 5. All right. So how are we going to, deal with this multiplication? So we have 16 times 9 times 5. 16 times 5 times 9. 16 times 5 is basically, 16 times 10 divided by 2 times 9, which is 8 to multiply with 10 times 9, which is 80 times 9, which is, okay. Or you can do 8 times 9, 72, then times 10. It's up to you. All right. Should be simple enough for the multiplication. All right. Okay. Lastly, very lastly. Oh, not yet, not yet. We have rational and irrational. Okay, so next up we have rational. Rational comes from the word ratio, so it can be expressed as a ratio. P over Q, where P over Q's, where P and Q's are integers. For example, we'll talk about 5. Why? Is because 5 is 5 divided by 1. Both of these are integers. We'll have negative 3, which is negative 3 over 1. Both of these are integers. We will have things like 2.5. 2.5 is simply 5 over 2. Okay, which is also an integers. Okay, we will have things like negative 1 over 3 also being irrational numbers. All right. Next up, we have irrational. Okay, so the prefix ir is going to be cannot be expressed as, okay, cannot be expressed as a ratio P over Q, where P and Q are integers. Okay, so um, we will not know why in this syllabus. If you truly want to know why, um, I don't think even A levels is going to teach you. Okay, if you want to know why, you can either go to the IB or you go to university to know why these following numbers are irrational. Okay, so we'll have square root 2, we have square root 3, we have square root 5, we have square root 6. We have pi and we have something called E. All right. E is not in our syllabus. It's going to be in additional math syllabus 0606. And it is going to be in your A2 mathematics. Okay. Which is second year of the A levels. All right. Um, Now, most of the time when I see these irrational questions, it is going to be in your calculator paper. Okay, so even though this is non-calculators, I'm going to tell you some tricks to use when it comes to calculator paper. When it comes to the calculator paper, punch this into your calculator or punch the numbers that the question is giving you into the calculator and try to press the fraction conversion. If you can press the fraction conversion and it show you a ratio, it is going to be rational. And it doesn't turn into a ratio, it is going to be irrational number. Okay. Um, if you practice and you don't see how it is done or you don't understand, please shoot me a message. I'm going to explain to you. When you shoot me a message, please give me the calculator model, and it's better if you can take a picture for me of your calculator. All right. Okay, and very lastly, we have reciprocal numbers. Okay, so what are reciprocal? Okay, so reciprocal of, let's say, the reciprocal of A is 1 over A. Okay, so for example, if it's 3, it is going to be 1 over 3. If it's -5, it's going to be -1 over 5. If it's 2.5, you first turn it into 5 over 2, and then the reciprocal of it is going to be 2 over 5. Okay, so on and so forth. All right. So, here are the questions you can practice. Okay, let me know if you have any problems. Ask me any questions if you don't understand of the parts here, and then along the way, if you do, if find any thing that is you're unsure about, please let me know. Okay, so I'm going to wrap up for the first standard in this 0580 syllabus. Okay. And I wish you have a nice day. Bye bye.